Today is the 6th.
Yeah, okay. Hi, everybody. Welcome to SIG Testing. It is Tuesday, June 6th. And I'm going to hand over to Eric Feda from Google to talk about Prowl.
All righty. Thanks. Let me bring up the presentation and figure out how to share my screen. Okay. Yeah, so I actually gave this to some people at Google because various people at Google are interested, and but I think it'd be interesting for all of us in the Kubernetes community, since some of us are more and less familiar with prowl. And so, let me send, or I'll put a link into this. Let me do that now. Put a link into the SIG channel. No, it's not right. Well, all right. Well, maybe someone else can do that. But there are links here. And so, so sort of some background on Kubernetes, which I assume a lot of us should be familiar with, which is that, okay, hold on. Yeah, let me give a link to the presentation. That'll be more helpful. Okay. And yeah, so, Kubernetes is a popular project just in terms of what it does on GitHub and the CNCF. There's tons of issues. There's lots of PRs going on. And so we have a lot of automation needs. And we've kind of grown out of, our ability to satisfy all of that with Jenkins. So we are building Crowl, which is a app that runs on Kubernetes to handle similar things. And the key, goals that we had for Prowl are that it's sort of an event-driven workflow where you can think about the main concept is that it reacts to events, typically GitHub events, but it could also be timer events, and then it does something such as change a label or schedule testing. And then the idea also is that we have different layers of our test infrastructure, with Prowl being on the top, and then Prowl, schedules pods, and then pods do something simple, which then is using this Bootstrap library, and then they call Bazel to build, and then we eventually call kubetest to run tests. But the idea is we have a different layers, and then each layer is only responsible for certain things, and that the interfaces between those layers are simpler than they were in the past. Because historically, we sort of had things in giant shell scripts and or a bunch of different Jenkins plugins, and it was very hard to sort of tease apart what actually happens in a given job, and we want to make that clear. And the third thing is we want to make sure that everything is accessible to the public. We, initially, I guess a year and a half ago, the state we were at is, the best way to debug something was to find, your favorite Googler friend, since our Jenkins infrastructure is running on Jenkins machines that we didn't feel comfortable making publicly accessible. And obviously that is not a super great experience if you are, one of the many developers who are not at Google. So we wanted to make sure that everyone has an even playing field, where the best way to deal with test results is the same. Is one, it's accessible to everybody, and that that people inside and outside of the company of Google all have access to the same tools. And so the basic idea of prowl is that you have a is that, like I was saying earlier, that prowl responds to events. And so initially you get some sort of event. The main concept is you get like a GitHub hook event. And then prowl will respond to that by creating a prowl job, which is a third-party resource. And then so that third-party resource is picked up by Plank, which is sort of our controller for prowl jobs. And then it is going to create a pod. And then basically, from Prowl's point of view, it doesn't really matter what happens inside of that pod. It just waits for it to finish. And then it will create the status line in GitHub to show that that happens. And then we have Deck, which displays a nice dashboard. That's the prow.kates.io. And so then, inside of the actual pod, there's the Bootstrap library, which its job is to make sure that the repo is checked out at the right place, and then it starts the actual testing, and then captures any log outputs, and then uploads everything that happens to GCS. Right. So
real quick, just
yep.
Can you point at what you're talking about when you talk about it? Because it's a little this is a little information dense for me, having never seen any of this before.
Yes, sir. Hold on a second.
Wow, I made him leave.
Yeah, so I'm going to go through all this in more detail.
Okay, sorry. Thank you.
Yeah, so that was sort of just a quick overview, right? So the initial thing, right, is the first thing, the sort of bulk of prowl is that it responds to events. And so if you're familiar, GitHub, you can configure GitHub to send whatever application. You can essentially say, hey, GitHub, anytime something happens in my repository, I want to configure it to send a notification about that to this application. And so, it could be I leave a comment, or I change a label, or I push a commit, or I merge something. GitHub will then send all of those events to prowl, and then hook is the application on Kubernetes that is configured to receive that event and respond to it. And so typically, then there's a bunch of different plugins in the prowl directory that will do different things. Typically, the most normal behavior is going to be to change the issue some way. Like if you've used the /assign command or the /lgtm or various things like that, right? That comment is going to send a event to Hook. Hook is going to look at it and go, oh, okay, great. I'm going to send this to the assign plugin, and the assign plugin is going to say, yeah, this matches something that I want to react to. And so it's going to react by changing the assignees to assign you or whoever you specified. The other big thing, like, is if you say at Katespot test this, same thing happens. That comments, GitHub sends an event to Hook. Hook processes it. It sends it to I forget what the name of the plugin is, but that plugin will create a prowl job and then wait for that prowl job to become finished. And sort of over time, we've actually had a growing number of people who are extending this by adding new plugins. And so yeah, and then also there's actually someone, I forget the name of the person, but they're from IBM, and they have a PR out to extend this to make it to where we can respond to Slack comments. Actually, I think for right now, maybe it's just sending something to Slack. But like theoretically, you could also, extend this to where we, instead of our just following GitHub events, we could make it respond to Slack events or other things. But yeah, basically Hook's job is to receive events and then pass it off to a plugin, which can do whatever the plugin is configured to do.
Is that literally a thing called Hook?
Yes.
Okay, got it. Thank you.
Yeah, so if you go into test info repo, there's a prowl directory, and then in that, I think there's a CMD subdirectory, and in that is Hook. And there's some documentation to help you find all these things.
Yeah, sorry, I'm a total newbie, so I've been gone for a while, and I just finally was able to start attending the meetings because of the new time. So
Yeah, no.
thank you.
I appreciate the questions.
Srini is the one who's doing the Slack thing. He sends people information.
Yep.
Thank you.
When you request testing, the plugin will create prowl jobs to signal that, hey, we want to eventually have some testing happen. And then Plank is the controller that is responsible for making sure that we actually schedule pods that complete that test request. Right. So now these the way the Plank controller works, right, is it is scanning the Kubernetes cluster for prowl jobs, and then noticing if there are any new prowl jobs that it doesn't know about. Usually something comes in from a Hook event, but there's also various other ways. There's a horologium binary that runs in the cluster, which is responsible for handling periodic jobs that start based on a timer basis, as opposed to a commit or some sort of event. And then theoretically, you can also create them manually, just using kube control. You can sort of say kube control, create this prowl job with the specifications. And if you use kube control to apply that, then magic things happen. And so the Plank controller is scanning for these prowl jobs that need to exist. And once they do, then it will create a pod that satisfies that prowl job. And then that is actually the pod that it creates is specified in the prowl configuration. And so you can configure it to start whatever pod you want. And then it sort of just keeps waiting for that pod to complete. And then it writes that status back to the prowl job. So Crier is a piece of prowl that is responsible for making sure the green check marks or whatever, the check marks in your PR status match what is actually happening with the prowl job. Right, so the Plank controller is sitting there, it creates the prowl job, then it monitors the status to see whether it failed or started or passed or whatever, and then it sends that status to the Crier binary, which then knows how to convert those prowl job statuses back into GitHub contexts. And so everybody is familiar with the submit queue. So then the submit queue is constantly looking at PRs, waiting for PRs that have all the right approvals, as well as all the GitHub context to say that testing has passed. And then the submit queue will actually do the merge. So reviewing, the basic flow that all of our testing works is GitHub pushes some event, most likely because I either merged a PR or I made a comment requesting testing. That gets picked up by Hook, which then sends it to a plugin, and that plugin creates a prowl job. The Plank controller detects this new prowl job and creates a pod that satisfies that prowl job request based on the configuration. What happens inside of the pod, prowl doesn't really care about. It's up to the pod to do its thing. It just waits for the pod to complete, and if it completes successfully, it marks the job as passed. Otherwise, or whatever the actual result of the pod, it updates that to the prowl job and sends the result to the crier, and the crier writes the context. It sort of converts that status back into a GitHub context and writes that to GitHub, and then our merge bot is looking for PRs that have all the right context, and when they do, it'll then merge them. So, let's see. I mean, I think is anybody interested in a demo of any of this, or what would anybody be interested in seeing? I assume everybody's familiar with the general, workflow of putting a comment on things and having things happen.
How about you demo the awesome new retest thing? Oh wait, that doesn't really hook into Prowl, I guess.
No, that's part of Prowl. That's the Prowl plugin that handles that. Yeah. So so if we look at let's see. If we just have something that fails tests, the exciting new thing, is previously I would have to, specify, leave a comment for each thing that I wanted to test, and then I would leave that comment, and it would retest everything. But now Ryan actually just made a change to the plugin to accept retesting, so that now if I just say retest, it will detect that, hey, these two jobs, for this PR, these two jobs aren't happy, and it will reschedule just those two, potentially eventually. And let's see. So some other changes is there's a change going in place to where, okay, there we go. So, okay, great. So lots of exciting things happen there. And then if you go to prow.kates.io, we have a quick little dashboard that shows everything that is happening. And so we can look for that. What is it? 4.7. We can see that my test command has requested those three things to start. The yellow circle means it's in progress. The green check means it's passed. The X means it failed. The little hamburger icon gives you logs. One thing that's nice with that is it shows real-time logs. So this allows you to debug your PR as it is happening. And so you can just refresh the page to sort of see whatever the latest thing is. And then this dashboard is pretty nice if you're wanting to, debug stuff. Like we have batch merges, and so that's a pretty common way for me to check and see if anything is, if our PR jobs are healthy or not. And then the circle shows the I was mentioning how you can just manually create the prow job, which I think is a pretty slick little behavior. So how this works is you can just say cube control create this, and assuming you have access to the prow cluster that this runs on, you can just create the prow job. Now, of course, creating the YAML is sort of a pain, so prow makes this easier by, if you actually just open this URL, it'll print out the spec for running the job.
Can you zoom in on that just for a little bit, just for the purposes of the recording? Whoops.
Yeah. Let me Yeah, so we can see here that so this sort of just spits out the pod spec that was used to create this pod.
Cool.
Let's see. Okay, yeah.
While you were bouncing around deck, I had a question about the individual pull request jobs versus the batch jobs. I'm guessing, I'm not sure. It seems like when I first submit a pull request and all the jobs have to get triggered, that's going to be jobs that are running just for my pull request, but then the submit queue needs to do a final run for everything before it merges, and that's what happens in a batch, or does everything get pushed through the batch thing? Just trying to figure out like which of the boards should I go look? Should I look at batch or should I look at pre-submit to go find my PR is the question.
So when your PR is on the, so like if you look at the top of the queue, right? So it's currently running this guy, and then it's also running a batch of a just slightly different set of PRs. But you can actually see that the merge bot talks to prowl. So I guess 25 minutes ago, the submit queue was free, and this was at the top of the queue. So it validates that, like, hey, maybe something weird happened between when I tested this, 3 days ago and now. So it leaves a comment for on the PR, which triggers, which results in prowl retesting the PR. And so then the submit queue, once it notices that, okay, it's aware of like what commit was tested against. So it's like, okay, great, this PR has passed all of the contexts at head, so I'm going to merge it. And then the batch behavior is slightly different. It's a little bit foggy, but I think there is something else in the merge bot that is makes a request directly to prowl to start a batch given the top 5 things on the queue. And then if there's some logic in there to like make sure that if the if the first one, if the non-batch testing finishes first and then merges, it's smart enough to know that, okay, great, I have tested this plus this PR, I've tested head plus this PR plus these other 4 PRs, and everything passed, so I'm going to merge the other 4 PRs.
Cool, thanks.
Hi, where does the code behind MergeBot run?
That's in Munge GitHub.
Munge GitHub, okay.
Yep. Let's see. I don't know if there's anything. So let's see. So on the PR dashboard, right? The PR dashboard is pretty fancy. Hopefully everybody is somewhat aware of it. Now, one thing that you might not be as aware of is if you just go to /PR, you can log in with your GitHub credentials, and then it'll know who you are. And then that enables ACK behavior. Like if I am not really interested in this PR right now, but I don't want to leave a comment on it, I can just click the ACK and it'll remove it from needing my attention. And then if you haven't seen this already, it's at the KatesKubernetes appspot.com/PR. And it has a simple sort of state machine that shows which of my PRs need my attention or not. So like, I guess this one, it thinks it needs my attention because like if I push because basically Sin gave me some comments a few minutes ago. And so if I then go reply to it, now it will, once Kubernetes gets the event, it should toss it off of needing attention from me and it should now need attention for Sin, and it'll show up on his dashboard. And then, so some recent improvements there, right? That we're now aware of things that I can approve, and yeah, so that's pretty cool. I think it's super helpful. So if you're not using that and you have a bunch of PRs assigned to you, I would encourage you to try it out. So on the config side of things, oh yeah, and so that code lives in Kubernetes. Yeah. Let's see. So configuring it in the prowl directory, there's a config.yaml, and so this has 3 types of jobs. We have pre-submits, we have post-submits, and we have periodic jobs. Periodic jobs are essentially things that run on a timed basis. So most of our CI jobs, so like our upgrade jobs, they just sort of run every hour or every day or however we configure them to run. Post-submits run whenever we merge a change. And then pre-submits run on unmerged pull requests via the comment that we are most familiar with. And yeah, so you basically choose a job name and then configure the pod spec. Here is what the configuration looks like. So prowl can work with, we actually have it, there's multiple orgs and multiple repositories that we are, that prowl is managing right now. And so you just sort of list, here is saying I want on repo 1 to run the foo job, and the other job in repo 1, and then in repo 2 I want to run this other thing. So you can kind of just configure it to do whatever you want. The rerun command is what sets the comment that will trigger the job. So in this particular example, the trigger is the regex that matches. So if I say at katespot test this, or at katespot foo test this, this will cause the foo job to run. And then, then we also provide a concrete example of the command, which is what appears when the job fails. It'll give you a comment that you can leave to request the job to run again. Post submits are the same, except that they don't have the rerun command, because they just happen whenever a merge happens on a particular branch. And so you can, by default, it'll happen on any branch, but if like your job only is relevant for the master branch, you could configure it to just run on the master branch. Periodic jobs are even simpler in that they just specify an interval. So this one is configured to run every 24 hours. And this is essentially the value is the Go duration format. So I guess I could say 1 day, 50 seconds, etc. So over time, so let's see, yeah. So now, the trick is like what actually happens inside of, actually, before I go on, any questions about the configuration or anything you want to see about that?
I just want to throw out a time check to see how folks are doing here, because we're way over our usual time. I personally am finding this interesting and happy to let this run as long as we need to. Otherwise, if too many folks need to drop off, we could break it up into another follow-up next week. Silence means I think we're just going to continue.
Okay.
Cool.
So then, what actually happens inside of the actual pod? And over time, we actually want to make it largely where the pod doesn't have to worry about things. Like, we'd love it where you can just assume that your pod starts, and we will mount the repository that you want to check out in a particular location, and anything test artifacts you want to leave, you put in a particular location. That's sort of improvements that we're planning for the future. But right now, you actually have to, your image that runs that runs in that your container runs needs to be aware of all that. And so Bootstrap is our library that handles that. And so Bootstrap's job is essentially to check out the repo, call the actual testing, and then upload the results to GCS. And so then within that, we have a couple different scenarios. So like, for example, a lot of our testing are variations of EDE suites. And so we have a Kubernetes EDE scenario that we pass different flags to, which is what distinguishes the, COPS EDE from the GCE and the GCE serial from the, GCE slow jobs. And and so but the other thing is it used to be where there was a ton of different commands that ran in a bunch of different Jenkins plugins. The mode that we went to now is you clone the test info repo and then you call the Bootstrap job, or you call the Bootstrap Python binary. So that sort of defines the interface to enter our testing. And then Bootstrap, all we want Bootstrap to do is that logging. And so the scenario is what actually handles calling kubetest, and then kubetest is responsible for, in the EDE scenario, doing all of the EDE things. So the goal is that you can mimic what any test job does by sending a command to kubetest, which is what, if you're familiar with the go run hacked.go, that's essentially calling kubetest. And so, you just call kubetest, passing flags to build and stage, etc. And then, and so that's what we do for our EDEs. We put all that into an image, and then we put that image into our pod spec. Yes. So literally everything that our testing does is some variation of these two commands. Clone test infra, call Bootstrap, saying what job you want to run, what repo you want to check out, and where you want to upload the results to. This has been a lot nicer than trying to keep all of our Jenkins plugins up to date, especially because it seems, at least our experience has been that if you have a non-trivial set of Jenkins plugins, it is challenging to find a version of Jenkins that is compatible with all of the Jenkins plugins you have, or at least a working version of all the Jenkins plugins you have at the same time. And so, like I said before, Bootstrap's responsibilities are to log the test output, check out the repo, and also it handles timing out, and then upload stuff to GCS. So the scenario is mostly just to make sure that Bootstrap, rather than having to call 50 different commands, it just can call a single command. So ideally, we'd like to get to where everything is just a single command, like the kubetest command. But in reality, there's sort of some complications due to historical reasons. So for example, what we really do is we have to set a bunch of different environment variables. And so we have the Kubernetes EDE scenario that handles all of that. And so kubetest is what actually does everything once the environment variables are set up correctly. So here's an example command. You have build equals Bazel, stage equals GCS foo, extract equals local, up, test, down, and dump artifacts. So that is saying that for this EDE run, we want to build Kubernetes using Bazel. We then want to upload this release to the foo bucket via the stage flag. We then want to download and extract the version. So you could extract, maybe a more interesting example would be like v1.6 or the latest CI passing build. Up says to deploy a cluster. There's also an interesting thing. There's like a strategy flag, which will let you flip between the cluster scripts or COPS or Kubernetes anywhere. And theoretically, if there's some new strategy that we want to add for cluster lifecycle, we could add that as well. And then there's test. which says I want to actually run tests after I deploy my cluster. There's a test flags and test args flag. There's a bunch of other flags to further specify the exact testing I want to do. And then down says to tear down the cluster after I'm done. And then dump says to put like JUnit results, as well as if test fails, it will potentially, at least on GCE and GKE, try and collect node logs and put all those into the artifacts directory. So again, the sort of different layers are that that our container will clone test infra and then call the bootstrap, which is in test infra. Bootstrap then is responsible for checking out the repo, logging the output from the scenario that it runs, and then uploading all of the artifacts created by that scenario to GCS. The scenario handles configuring the environment and calling kubetest. And then kubetest does the actual interaction with Kubernetes by deploying Kubernetes, running tests, grabbing debug logs. Each of these is essentially one command. And then we put all of this inside of our kubekins Docker image. Yeah. So I actually don't know if there's a super easy way to do that. Let's see. So another, let's see. So I guess maybe this can be a plug for some other interesting tools that we have. Hopefully people are familiar with TestGrid, which has all of our test results. So if you want to see, what happened with the 1.6 blocking jobs, you can go here. Each tab is essentially a kubetest invocation that runs continuously on different commits. So this is showing that, at 6 or 7 a.m. this morning at this commit, we deployed a GCE cluster and ran all these tests. Since there can be a bunch of it can be time consuming to go to all these different tabs. So each dashboard has a summary tab. And this will sort of give some statistics about how frequently it fails. So it looks like the build job has not failed at all this week, whereas the GCE job failed 25 times out of 14,000 runs. And the kubeadmin Kubernetes Anywhere suite looks like it's failed twice. And then even more interesting, these specific tests are highlighted because they are consistently broken as opposed to just flaking. So if I go here, I can see that those looks like there's something wrong with this test for who knows what reason. And yeah, so that sort of shows that there. I guess it looks like also in the reboot suite, these reboot tests are failing. Something that we have been investing in, which I would really like to see more of, is giving each SIG their own dashboard. I think this could sort of help with triaging different bugs. And so one thing that TestGrid does, which is nice, is it allows you to filter things. So like if we compare, if we compare the regular GCE suite with the CLI GCE suite, you can see that this here, the SIG CLI team has said that these are the only, we're only interested in jobs that have the kube control client name in them. We don't compare about the config map or the deployment, et cetera, tests, which you can, if you click on the options, you can do that filtering yourself. But one, that doesn't exclude it from coming up in the summary. And then also it's sort of, if you have new members on your SIG, they might not be familiar with the, weird, complicated regex that you need to filter out results. And then also for some people, some jobs might not be relevant to their SIG. So all that configuration is in if you go into test infra test grid config, there is the config.yaml. And so you can see that the way this works is this test group. That's going to be too many. But so each test group is essentially a prefix, GCS prefix, where a bunch of test results are stored. And so we're saying to use these test results, but I want to filter down to only things that contain kube control. And so this might be useful for other SIGs to sort of set up their own dashboards that give them a quick way to just check the summary and go, hey, life is super happy in my world. There maybe these tests are failing, but I'm confident it's not because of my tests.
I had a quick clarification on test grid. So first, there's a question from the chat about, is there like a good default dashboard that we should be dumping people at instead of like showing them 20 different gray blocks? Could we just dump them straight away at a dashboard that they find useful? Right.
Yeah. I don't know what that would be.
That's kind of my thing. Like, I don't know. I think our goal, I think a compromise we could maybe make is we're lacking descriptions for what all of these are. And so in that config YAML, I believe we could probably add a description field that somehow this, instead of a bunch of blocks, could get rendered as a table with descriptions or something, or the descriptions could be tooltips. I do think the default kind of matters. Like, should I care about 1.7 right now since we're in the 1.7 burn down? Should I really care about everything that happens with master? Am I coming here to troubleshoot what's going on with COP specifically, et cetera, et cetera? So I think, Morgan, I think that would be a great issue to file. The other comment I had was, I think the percentages that you were showing on the summary tab are percentages of test cases, not job runs specifically. Unless I'm misunderstanding the summary tab, it seemed to imply there were like, hey, let's go. Okay, GCE, were there really 12,691 runs within the last week? Or were there 12,691 test cases exercised in the last week?
Yeah, I think you're probably right that it is test cases rather than runs.
Okay. Yeah, I'm still going through a backlog of notifications, but if there's not an issue for that, I'll file an issue just to clarify. If nothing else, the language percent, 92 of 12,691 what would be really helpful for me, because the percentages are really low. I'm just trying to understand what the percentages of.
Right. Yeah, that makes sense.
Cool. Okay. Sorry for interrupting there.
Yeah, no, I mean, I think that's basically it. There's Velodrome. If you guys go to, let's see. So one other thing is if you go to GitHub, all of this stuff should be on the README. So there's, there's links to test grid, the PR dashboard, prowl, etc. I guess one thing that's not on here that should be is Velodrome, which has some of shows some statistics about. So this is built on top of Grafana and InfluxDB and Prometheus. So one fun thing is, I guess it'll show if we're like running out of tokens for the merge bot. So that is a problem that slows down the merge bot, which we would like to potentially fix. I think this one doesn't work very well. But yeah, so this will show, for a given week, how many different pull request authors there were, etc. And so we're working on, if you look at the metrics, we've been running some metrics to sort of calculate, how how consistent jobs are. You can see that we sort of headed south in the past month, and we're now calculating all these metrics automatically, and we are working on Cole is actually working on putting this into Velodrome.
In fact, as I recall, the metrics are being computed by a prowl job, which is being scheduled by Horologium, however you pronounce it.
Horologium, yes. And Horologium is the clock constellation, in case you're wondering where that name came from. But yeah, so if we look at the prowl config, you can see this, where it runs every day. It runs this image and sending these things to it.
Okay, this is really cool. Thanks a bunch. For me personally, I feel silly saying this is like a co-lead of SIG testing. Like the bootstrap stuff has been way over my head. So understanding the layering is helpful. I'm still not quite at the point where I can repro it on my own machine just yet, but it seems like bootstrap is the place to start. So if I want to understand exactly how prowl does it, I should be looking at bootstrap. If I just want to get something up and running with the cluster I have from my own machine, I can maybe send the right set of flags to kubetest.
Right. Yeah. So yes. So theoretically, it all boils down to calling, setting environment variables and calling kubetest. And yeah.
Cool. Well, again, thanks so much. This awesome presentation for the inaugural recording of SIG testing. Does anybody else have any questions?
That was awesome, man. I really liked it. It would be great if we had some kind of a tutorial on sort of like, hey, I got a bug and I had a failure. What's the sort of workflow to go through and diagnose it to figure out what tests are failing and how to understand what's going on? For new contributors, that would be really super if there's something like that.
What he just said.
Yeah, I think part of the problem is, like I think historically everything's kind of been bespoke, right? That's sort of why we're trying to get to where every job calls, clone test in for a call bootstrap, because then we can start, giving best practices. But like part of the problem, I think that's actually a really good idea, and we can work on something like that. Some of the challenge is going to be like the EDE jobs are going to have a different debugging strategy than like the unit test failures. And then we have like the test integration and test CMD jobs that like they don't even produce JUnit output right now. And so they don't show anything on test grid. And so, over time, if we could get to where they're sort of, whether by using, if we could get to where all jobs have like the same output that they give, that would, I think, assist with making it easier. But yeah, it can be, we can definitely provide some, assistance there.
Yeah, I would say that could be a great walkthrough for a future SIG testing meeting if somebody wants to try giving that a shot. This is part of the reason I'm trying to pay as much attention as I am to the release, to the latest release. Even though I'm not a member of the release team, I would like to go through as much of the triaging and debugging process as my time allows, so that I can sort of help with this sort of thing. Because the only way we can improve our test flake failure rate is if we actually grow the pool of people who know how to troubleshoot test failures. And at the moment, we're kind of in this chicken and egg problem where the people who are really busy improving the test infrastructure are kind of also the people who have the insight into what test infrastructure to do. So I would, Kubernetes is a really, really awesome place to start. There are so many links to so many of the other things. And then I think between this presentation, which I cannot promise I will have on YouTube today, but I will get this posted as soon as I am able, and the README and the test info repo, most of the stuff is decently up to date. It's significantly more up to date than it used to be as far as docs go. And if there are places where that's not true, please come bug us in Slack and we'll do what we can to resolve it. Cool. So I apologize for this running significantly longer than we're scheduled, but maybe this is something for us to discuss later, whether or not we want SIG testing to be scheduled for longer than half an hour going forward. And I think that's all I have.
And thanks for your copious time giving me.
Cool.
Thank you.
All right. Thanks a bunch, everybody. Happy Tuesday. See you later.
Thanks a lot.